Hello, my name is Klaus Grobe and I'm heading the Sustainability Department for ADVA Optical Networking, and I'm also leading ADVA's part in the EU Horizon 2020 research project C-Service. And in this short video I will give some explanations and information on our part of the demonstrator of this project. One slide on ADVA. ADVA is an ICT infrastructure provider. That means you can find our equipment inside enterprise data centers, in the cloud, connecting data centers and access points, and in network provider networks, for example, in the form of optical transport equipment, and also in the access part, connecting enterprise customers to the networks. Why are we participating in this project? We already had several circular economy mechanisms and processes implemented. For example, a process where we analyze all equipment sent back or returned to our logistics hubs for any possibilities of further future reuse. We also have some guidelines that address circular economy in our internal eco-design guide. And we tried some first leasing projects. I will come back to that later. Regarding our packaging, most of our packaging is reusable and some of the packaging is also plastic free already. However, it turned out circular economy didn't really work on broad scale for us. There is very different expectations from our customers, ranging from interest but not implementing it, up to no interest at all. And we have to say that all our leasing attempts in the last years failed for several reasons. And that's why we wanted to understand circular economy in a better way and participated. Why did we choose the ALM product? ALM is the Advanced Link Monitoring. It may look as an atypical product for the ICT space. In effect, it isn't. For example, regarding its use mode, it's very similar to all our other product lines. The use mode is 24/7, always on. It also has very long lifetime, which some of our other products have. And if we look at the optoelectronic components and some other details, there's practically no difference at all. In other words, what we learn for the ALM, we can also extrapolate to our other products. As already mentioned, the ALM indeed has very long lifetime. It is somewhat less subject to functional obsolescence. So ALMs can stay in the networks or in the infrastructure for clearly more than 1 decade. And an interesting aspect of the ALM system is that it splits into a certain number of passive fiber optic sensors and an active unit, which then monitors these sensors. Let's come to the first phase of the demonstrator, the design and production phase. Within the project, we designed and developed 2 new sensors for the ALM system, a fire sensor and a door opening sensor. So these new sensors also extend the application range toward more than just ICT networks. Both sensors can be used in monitoring buildings. And we developed these new sensors using life cycle assessments, for example, in order to choose the main respective material for these sensors. Finally, the sensors will be made of aluminium, primarily because of their enormous lifetime of 2 to 3 decades, where we would have problems with plastics due to aging. However, we can use secondary market or recycled aluminium. Some work was also done on the active units. Our project partners disassembled a handful of these active units. And what we found is quite a number of different small plastic parts, which you can see here, different size, different color, different material. And this will have a clear effect on future releases of the ALMs, but also of other products we have, because we will consolidate over time the number of different plastic types and different colors, etc., that is used in our products. We identified several challenges, mainly most notably almost all our products are dominated in life cycle assessments by their use phase energy consumption. This has some impact on eco design because we need to concentrate on energy efficiency. And also there is sometimes little choice or little alternatives or few alternatives. For example, with regard to components like ASICs, application-specific integrated circuits, because these need to be chosen based on functionality, not primarily on circular economy aspects. That gets us to the second phase of the demonstrator, the use phase. We implemented the demonstrator as a simple product service system, PSS, where we sold the systems together with a maintenance contract. During the use phase, there was no take back or returns of parts of ALM systems whatsoever. That's primarily due to the long lifetime, so no news to be reported here. And that's why we complemented the practical demonstrator by extensive studies on lifetime optimization and on product service systems. For the lifetime optimization study, we defined a new parameter that we call UPR10, which is the global warming potential of the first 10 years of the use phase over the global warming potential of the production phase. And this relatively simple parameter can indeed be used to identify products where replacement for reason of energy efficiency and energy consumption does make sense in order to optimize total lifetime global warming potential. This is not the case for the ALM, which we can see here. Once installed, it can stay in the network or in the infrastructure for decades. In case we would replace it later by a more efficient unit, that's the solid curve, this scenario would never meet the original lifetime global warming potential. Regarding product service systems, we investigated several types of PSSs. We investigated several products, not just the ALM. We considered all relevant monetary and environmental parameters. We also considered both our view as the selling or offering party and also the customer's view. And what we can say so far already is that certainly several, not all, but several product service systems are clearly viable and will be implemented in the future. Gets us to the last demonstrator phase, the end of life phase. We are working on some analyses for improving recycling. This includes that we will compile a generic disassembly guide, not again, not just restricted to the ALM, but to general equipment. And we are also working on some aspects of reverse logistics and how these can support better efficiency in recycling. What we will not do is work on any new recycling technologies like, for example, hydrometallurgy and so on. We will further work on more product service systems analyses, especially with regard to the monetary impact of the end of life phase. And what we found so far is that for our B2B products, it seems that there is comparatively little advantage in terms of environmental impact of leasing PSS over other PSS which also contain take back at the end of life. So what seems to be relevant is the take back at the end of life, not necessarily the leasing. Leasing might be more interesting for monetary reasons. And then we continue some work on ICT tools and how they can support certain circular economy and in particular recycling aspects. And what we found out so far already is that indeed recyclers seem to have an interest in full material declarations, although these can be really complex since they contain all information on substances of all components contained in potentially complex products. And this is due to the fact that the FMDs do contain all information also on hazardous substances, which is of course interesting for recyclers. That gets me to the last slide. Lessons learned so far in conclusions. Our most relevant conclusion is that for at least certain product classes, we must look at energy consumption and how this affects total lifetime environmental impact. We know that at least for certain classes, the products must even be or should even be replaced by more efficient successors. This is certainly not true for all electronics and electrical equipment, but for some, and it should be checked. And we also see that in fast-paced markets like infrastructure ICT, there may be certain challenges with regard to functional obsolescence. So these two seem to narrow down circular economy possibilities, but certainly enough circular economy loops and actions remain. And in our case, for example, we will more likely concentrate on the most inner loop here and the outermost one with recycling. We also see that certain product service systems, again, not all, but some, are very interesting, and we will extend the respective PSS business, including first leasing PSSs. In other words, we will extend our circular economy business. Thank you.